Good morning, everyone. I'm Farhan S. from Sri Venkateswara College of Engineering. Today, we are going to talk about in the introduction of computer network errors, redundancy in network communication, error detection versus correction, error detection coding techniques. Introduction to computer network errors. Definition of network errors. Network errors are anomalies or disruptions that affect the flow of data across a network. These can occur due to hardware failures, software bugs, or environmental factors. Errors may result in data loss, corruption, or delays in data transmission. Common source of errors: hardware faults such as malfunctioning network cards or cables, interference from other electronic devices, or physical obstructions. Software bugs or misconfigurations in network protocols. Environmental factors like power surges or extreme temperatures. Impact of errors on network performance: increased latency and slower data transfer rates, higher packet loss rates leading to retransmissions and congestion, reduced reliability and potential downtime in network services, user dissatisfaction and potential loss of business. Types of network errors: single bit errors, errors that can affect only one bit within a data frame. Burst errors, error that can affect multiple consecutive bits in a data frame. Random errors, error that can sporadically and unpredictably across data frames, can be due to random hardware failures or unpredictable environmental noise. Systematic errors, errors that can consistently occur in predictable patterns, often due to persistent fault in hardware or software configuration. Error handling in networks. Error detection. Techniques like parity checks, checksum, and cyclic redundancy checks aims to identify errors in transmitted data so corrective actions can be taken place. Critical in ensuring data integrity and reliability. Error correction. Mechanisms such as Hamming code, Reed Solomon code, and forward error correction allow the network to not only detect but also correct errors in data transmission, essential for maintaining data accuracy and redundancy retransmissions. Error prevention techniques. Implementing a robust physical layer design to minimize interference. Regular maintenance and updates for both hardware and software. Employing redundancy and failover mechanisms to handle faults seamlessly. Redundancy in network communication. Definition. Definition of redundancy in network communication. Explain of why redundancy is crucial for network reliability. Discuss on how redundancy improves fault tolerance. Types of redundancy: physical redundancy in network hardware, logical redundancy in network connections and protocols, temporary redundancy to handle time and sensitive data loss. Trade-off in redundancy. Cost implications of implementing redundancy: complexity introduced by redundant systems, balancing performance and redundancy needs. Redundancy techniques, parity bits. Explanation of how parity bits are used for error detection, difference between even and odd parity, checksum. Description of checksum calculation, it is used in error detection. Common algorithms for checksum computation. Cyclic redundancy check, CRC. Overview of CRC and its role in detection data corruption. Different polynomial lengths. Application of redundancy. Network design considerations. Importance of redundancy in designing resilient networks. Strategies for implementing redundancy in network topologies. Data transmission protocols. Examples of protocols that incorporate redundancy for error correction. Benefits of redundancy in reliable data transmission. And redundancy in hardware components. Critical hardware components that benefit from redundancy. Methods for implementing hardware redundancy. Error detection and versus correction. Concept and purpose. Error detection algorithms such as parity check, checksum, cyclic redundancy check, hash functions. Error detection performance. Accuracy of error detection methods. Error correction mechanism. Concept and purpose. Definition of error correction. Importance in ensuring data integrity. Examples of error correction in real-world applications. Error correction algorithms: Hamming code, Reed-Solomon code, convolutional code, turbo code. Error correction performance: Error correction capabilities and limitation. Latency introduced by error correction. Perform impact on data throughput. Comparison and evaluation. Efficiency and overhead. Comparison of resource usage between error detection and correction overhead introduced by error correction mechanisms. Efficiency of implemented solutions in different scenarios. Complexity and implementation. Complexity of integrating error detection algorithms, challenges in implementing error correction techniques, comparative analysis of implementing difficulties, use cases and scenarios, situations where error detection is preferred, scenarios requiring robust error correction, industry specific applications for error detection versus correction, error detection code techniques, conceptual overview, definition of error detection coding, basic principles of error detection, role in ensuring data integrity, purpose and benefits, improve data reliability, minimizing transmission errors, increase efficiency of data communications, historical development, milestones in error detection coding, figures and their contributions, evolving of techniques over time. Common coding techniques. Hamming code, Reed-Solomon code, low density parity check code, advanced error detection codes, turbo code, serial and parallel concatenated codes, iterative decoding process, performance metrics, polar codes, channel polarization concept, encoding and decoding procedure, applications in 5G networks, fountain codes, concept of rateless coding, encoding and decoding mechanisms, applications in data transmission. Telecommunications, error detection in voice and data communication, specific coding techniques, used case studies of implementation, data storage solutions, importance and reliable data storage techniques used in hard drives and SSDs, real world examples, network data transmission, role in internet data transfer, protocols incorporating error detection, success stories and improvements. Thank you for watching. Please like.